The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to the CARILEC Renewable Energy Community Webinar Series. My name is Martin Ford, and I am the community leader of CARILEC. Today, I'm seeing quite a few names popping up in the attendee box who were here last month. And if you weren't here last month, we did a series focused on planning for resilience and disaster recovery at utility. And in keeping that theme of resilience, we're now focusing this session on some of the technology that can help you build resilience at your utility. So for those of you new to CAREC, CAREC is a free online community that we launched in 2016, and now in its 21st month, it has almost 900 energy practitioners from all around the world and over 42 utilities represent. So it's a free space for you to sign up and go and share your best practice with each other. If you haven't done that, I ask you to go to community.carilec.org to sign up, because I'll be placing this webinar, and you can find other webinars on there to view for free, and you can connect with our panelists. So today's Q&A session will also happen at the end of the presentations, and we'll have you guys submit your questions in the question box on the GoToWebinar dash. And we'll be monitoring that throughout the panel to let you get some input from our panelists. And what we've done, many of you, when you registered, you would have noticed that we asked you to submit any questions ahead of time. I've shared them with our panelists so that they've built it into their presentation. And anything else we can access via CAREC. So to start off, let me introduce you to someone who's not a stranger to the CARILEC family, Mr. Fred Kuvali of St. Eustatius Electricity Company. Back in November. Good morning, Mr. Kuvali. How are you doing?
Good morning. I'm fine.
Now, those of you who are new, back in November 2016, Mr. Kuvali gave a presentation on his PV system in St. Eustatius, and he reached out to me along with his development team from SMA Sunbelt Energy to give us an update on phase 2 of that development. And so joining him as well, we have Mr. Jesus Martinez and Mrs. Vibke Kruger from SMA Sunbelt Energy. Welcome to the show, guys.
Thank you. Hello, good morning.
How are you doing? Jesus?
We're doing good. Great. I'm excited to participate in the webinar.
Great. We're excited to have you here. So to give you a bit of background on our panelists, Mr. Kuvali is director at Stuco, and he earned his bachelor's in electrical engineering back in 1991 from University of Netherlands Antilles in Curacao. And then he went on to work at the utility Martin for a while. And then in 1994, he transferred back to St. Eustatius to run operations. He was appointed manager of NVGBE on St. Eustatius until the company was dissolved in 2013. And in 2014 was appointed managing director of the new electricity and water company, Stuco, in July 2015. He's responsible for all significant improvements with respect to electricity supply on the island of St. Eustatius for now 22 years. So we're very lucky to have him presenting his experience, sharing it with the CAREC community. Miss Vibke Kruger, she's head of project management and execution for SMA Sunbelt Energy. From 2000 to today, and responsible for the implementation of hybrid storage systems worldwide, and in particular the Caribbean and she was a key member of the project team on sending stations for phases 1 and 2 with Saba Island and also Padava. Excuse me. She previously collaborated as sales manager and project manager in the off-grid department, where she specialized on hybrid power plants and gained extensive working experience along with the whole value chain of hybrid projects in sub-Saharan Africa and the MENA markets. So we're very lucky to have her here as well. She holds a degree in industrial engineering from the University of Paderborn in Germany, where she specialized in electrical engineering. And she also studied at Queensland University of Technology in Australia. And to deepen her knowledge in energy efficiency, which is a big topic on many of our minds, she recently completed her formation as European Energy Manager with the Chamber of Commerce, Darmstadt, Germany, in addition to further training in project management. And finally, we have Jesus Martinez, who some of you already know, who is Business Development and Sales Manager for Hybrid Solutions and Energy Storage at SMA. There he's responsible for the development of local and regional markets in the Caribbean, and his working experience spans over 10 years in solar PV, battery, small and large scale systems, and hybrid projects, particularly in Latin America and the Caribbean region. And he worked in global energy development companies in Germany, such as GUI, Micro Energy, and Renewable AG, and previously in sustainability, safety, and environment projects in the manufacturing sector in Latin America. Jesus holds a Bachelor of Science in Mechanics from UNL, Mexico, and a Master of Science in Solar Technology from the University in Berlin, Technical University of Berlin. Guys, welcome to the show. Today we're going to start with Mr. Cavalli sharing his experience. So at this moment, Mr. Cavalli, I'm going to make you the presenter. So Mr. Cavalli, you should get a request for your screen right now.
Great.
Great.
Hello? Yeah, you can hear me?
Hearing you clearly, seeing it clearly as well.
Great. Good morning again to CAREC community. I thank you guys for the opportunity to allow us to present the solution that continues to work fantastic on the island of Statia, of St. Eustatius. And I trust that you will be creating some excitement and stimulate you and motivate you to push forward with your renewable energy plans and initiatives in your various companies. So without further ado, I will now present my role in this presentation. So next, oops. My screen seems okay, right? Okay, the solar and storage in Statia, the conception. Ever since prior to becoming Stuco, the operations on St. Eustatius was heavily dependent on where cost of operations was going for fuel. And once we became Stuco, the subsidy that was being provided by our pharma company, NVGBE, went to the responsibility of the Dutch government. And this subsidy was almost $2 million per year, as 78% of our income was going directly to pay for the fuel cost. So the Dutch government then sought a structural solution to offset the heavy cost of fuel.
Yes. I can come. Yes. Mm-hmm. Sure.
Okay. The tender process. Certainly, much focus was given on partnering with the right advisor or consultant. So in the beginning phases, we were purpose-driven to find that balance between the knowledgeable consultant and, of course, cost of the consultant. And however, strong focus was given on the evaluating of the technical components, the standards and codes to meet the challenges of our Caribbean environment, and certainly on Statia with a small grid of with a peak power of 2.3 megawatts, a complexity of maintaining grid stability in such an environment. As you can see, the solar panels, the requirements for the solar panels, complying with IEC 61, you can see the codes there. The warranty performance of the panels greater than 90% after 10 years, and 80%, greater than 80% after 20 years. The mountain structures were initially designed to withstand Category 4 hurricane force winds at a 15-degree angle, but later adjusted to 5 degrees. And the main purpose of that was to minimize or maximize space that was required, because St. Eustatius is a small island, and certainly spacing was, with the future outlook of our next phase coming, spacing was a very major concern. And of course, the PV inverters, you can see the requirements through the German Federal Association of Energy and Water Business, technical regulations, the battery storage and inverters, which provide grid stability, in our case, energy shifting and grid farming during power management control to enable diesel off mode. And these battery and storage inverters, grid farming inverters, comply to class G2 according to ISO 8528-5. The following picture demonstrates the requirements, the strength of our solar panels. There you see the lead contractor for the project, phase 1 and 2, of Eco Energy, Mr. Avelo, standing in the middle, in the most critical part of the panel. He's 95 kilograms, he told me, 96 kilograms, and the panel is just fine. And on the right shows a solar panel with a lower loading factor as the one on the left. Also, all parts of the structure, the critical parts of the structure, has to also comply with this Category 5 requirement. And you can see the brackets that were used and the forces that can be withstand in order to enable the structure not to blow away or break up. You can see in the bottom photo, to your 2 photos to the left, pictures to the left, the second one shows that bracket installed under the panel. Also, the left photo indicates the angle at 5 degrees and our guttering system for the collection of water that we are presently installing, which should be completed next month. To the right, you see the devastation on one of the Caribbean islands of the solar park that was not sufficiently strong to withstand the winds. And the bottom right shows the angle of 15 degrees versus the angle of 5 degrees that was installed on St. Eustatius. This next page shows the main components technology review of when considering to go have a PV application. If we start to the left, basically you can go up to 20% penetration, PV power penetration, without doing any making any considerations. Basically plug and play with your existing diesel generating plant. By means of a fuel safe controller, you can then, where the fuel safe controller manages the amount of PV power given the spinning reserve at the production plant, and the minimal load that is allowed on the engines at the power plant, you can go up to 60% renewable energy or PV power penetration with the help of a fuel safe controller for power management. In the case of St. Eustatius phase 1, where our focus was really to get rid of offset this expensive fuel, we applied storage in phase 1 with the main purpose for grid stability, and we were able to achieve up to 90% penetration into the grid, PV power penetration into the grid. And then for St. Eustatius, our phase 2 project, where we added a similar size as phase 1. When I say similar size, the requirement of PV energy in phase 1, the contracted or the amount in the tender was 3.2 gigawatt hours. We did not specify exactly the size of the PV system. This was left to the tenderers to be creative and come up with their own initiatives and expertise in determining what kind of PV panels and batteries they would apply to the system. Stuco firmly required that the net energy over 1 year that is exported to the grid of Stuco should be 3.2 gigawatt hours. And in phase 2, this was a similar requirement. And additionally, in phase 2, we required to get a bigger bang and speak more towards the resilience and the effectiveness of adding going green. Let me put it this way: we required that the system can operate fully independent of the power plant. So we required that we go to 100% PV penetration and shutting down the power plant automatically. Okay, this graph shows the SCADA that we have at the power plant. The power plant is located some 4 kilometers away from the solar park. So we have communications with the power plant via 2 distinct routes with fiber connection. If you look at the graph to the left, you will see this photo was taken, or this snapshot was taken on the 19th of December last year at 10:58 a.m. You would see at that time, in a moment of time, we had a PV power export of 3.3 megawatts, 3,379 kilowatts. And the diesel genset, you will see 0. So it was, this indicates the entire power plant was shut off. The load at the top right of the same graph was at the time 1,600 kilowatts, and the batteries were charging with 1,700 kilowatts. And there's a graph that indicates PV power. You can see at the time, of course, it's fully yellow. So we were 100% being supplied by PV power. And the second graph, or the one in the middle, indicates that we were already 2 hours and 26 minutes in diesel off mode. Then secondly, the picture to the right, or another of the SCADA, shows the short circuit capability at that time of the system was 16,700 amps. In order to decide the point to switch the diesels off, we should have minimal 7,500 amps of short circuit current capability, and also 30 minutes of estimated battery life. And mostly that coincides with around 20% of state of charge of the batteries. The following picture gives a summary of the solar park on St. Eustatius. The left gives you an overview of the solar park and the systems, and the written part indicates that we're Cat 5. We have 4.15 megawatts of PV power installed, 5.9 megawatt hours of battery energy, and with 4 MVA of diesel capacity. Also, the system comprises of 2 2200 kVA Sunny Central storage units with 2 medium voltage power stations of 2200 kVA, and also 1 phase 1 Sunny Central storage of 1000 kVA and 1 medium voltage power station of 1000 kVA. And then that is in combination with 2 Sunny Central units, solar inverters of 1000 kVA, and 1 medium voltage power station 2000 kVA, and phase 1 74 25 kVA Sunny Tri-Power inverters, and that with a fuel safe controller 2.0 with automatic genset shutdown and startup. The following indicates the path that Hurricane Irma took. Certainly, you will see that the time it hit St. Martin, listed as Cat 5, which we know from all information received, that when the storm hit St. Martin, it was over 200 miles per hour. St. Eustatius, Oranjestad, that's the capital, it's listed there in that second to right photo. We are located just 40 miles to the south of St. Martin, and knowing the size of the monster storm that it was, we know that certainly at least Cat 4 storms were experienced on our island. This is a visual of phase 1, August 15, 2016. And the second photo indicates phase 2. September 14th, after the passing of Hurricane Irma. The solar park was completely intact, thank God. And I will give then now a summary of what we were able to achieve on Statia. We have now a Cat 5 hurricane withstand solar park of 4.15 megawatts at a 5-degree solar panel angle. The energy loss, of certainly some of you may be wondering about that, or how much energy we lost. It was only when we reviewed the calculations before deciding to space the panels closer. We only lost, the calculations indicate only a loss of 1.04% of energy. But the land that we were able to save was, or for expansion, was 33%, as the spacing between rows was reduced from 3 meters to 1 meter. Also, solar allows another benefit, which wind energy does not, which is, in our case, we raise the panels 2 meters to allow for the coexistence on the property with another secondary activity. And this activity on Statia is very important, agriculture. So for this purpose, the minimum height at the front of the panels is 2 meters. And of course, agriculture needs water. Again, this is where the panels can provide added benefit. So we are expected to collect 2.6 million liters of water per year that will go firstly to support agriculture, but also Stuco is installing an auto spray system. So a small fraction of that water coming from that will be housed in our water catchment or system of 180 cubic meters. We will use that water cyclically to wash our panels from dust when necessary. We have now achieved a maximum renewable energy injection of 46%. Maintenance costs of the generators of course are drastically reduced because the running time has been drastically reduced and we go to diesel off mode. Grid stability, frequency and voltage are enhanced when in diesel, not only in diesel off mode, but continually, because the solar park continually functions as a backup. So the grid stability, frequency, and voltage are kept in margins that heretofore were impossible with our conventional gensets. And of course, when going to diesel off mode, you have to be able to deal with transients on the grid, such as grid faults. I can tell you that with our conventional diesel generating plant, we can only clear up to a 20 amp 3-phase fault without causing a shutdown. Anything larger than 20 amps on a 3-phase fault, which is the most critical fault, will shut our conventional power plant down. However, we have tested the solar park in diesel off mode up to a 40 amp 3-phase fault at 12.5 kV, and the system fully recovered to 300 milliseconds back to 60 hertz, and with only a glitch in the light seen around the island at that time. And it only took 30 minutes to shut down and protect the system prior to the approaching storm. And immediately once the storm had passed, the next day in 1 hour, the system was available to stucco again. I can tell you that lastly, we are looking, of course, power plant to be able to, there's one matter that's left to fully copy or assume all the responsibilities of a power plant for the solar park, and that's the black start. And so within a couple of months, we hope SMA is finalizing this development, and we will add the black start capability to our solar park. And you can imagine the park being able to fully supply the island with power, given any situation at the power plant, be it that a hurricane passed and our power plant is disabled, or a tsunami or whatever. We would then, during daytime, while the power plant is down or being repaired, still be able to supply the island with power once the sun comes up, because we can then black start the solar park and get it up and running and supply power, even though our power plant may be disabled. And with this, I hope to have provided an overview of what we have installed on Statia. Next will be Ms. Wiebke Kruger, who I was very proud of having her. I don't think if we had a man that the project would have been executed this effectively. Hence, I'm proud to have a woman in renewable energy join me in co-presenting here today. So I thank you for your attention.
Thank you very much, Mr. Cavalli. Just a note for the guests: you can submit your questions during the question box, and we'll be sure to ask these of our guests. We had a few come in, Mr. Cavalli, around what is, like, how much water was collected during the latter installed gutters used for. So did you use the water for irrigation, or in the gutters, or cleaning the PV?
Okay.
People were really impressed that they've never seen that attention paid to PV before, so they thought it was cool.
Great. I must tell you that water scarcity is a big problem on Statia, although our utility company is also responsible for the provision of reverse osmosis water to the island, but that's drinking water. And on Statia, we still have agriculture, and we are promoting large-scale agriculture, even for export. We have a lot of animals on the island, and during drought, animals are dying, and the agriculture becomes compromised because there's the availability of water is non-existent. Wells are drying up. Therefore, solar park provides an excellent basis. Firstly, of course, we considered collecting some water to be reused for washing our panels, but at the same time, very quickly we realized that we can actually expand this in a major way to contribute significantly, or add the most significant component to the concern for the success of agriculture on our island. So with this, we have 13,000 panels of almost 2 square meters. I think they're like 1.95 square meters each. And we can collect, given the expected rainfall on the island, 26,000 cubic meters, or 26 million liters per year. From that, we only require probably 180 cubic meters. So the overwhelming amount of water will be channeled to a water catchment system of the island government, and from there, private third parties will be able to tap that water and use it for their agriculture, also feeding animals, etc.
Thank you very much.
Yes, I didn't mention the project. The guttering system is completed. However, the project itself in running, channeling the water to our already built system, this will be completed in 2 to 3 weeks completely. And then we will have the system completed, and we will just wait on rainfall, fill it up, and the government also is expected to put in their water catchment system within the next month. They should on the property by gravity, the overflow from my system will feed into their water catchment system.
Okay. Thanks a lot for shedding some light on that. And I believe you guys had some questions for the audience, some polls. I was going to launch two of them before I hand over to you, Vibke. So attendees, if you look to your screen, you will have a poll. I'll give you guys a minute to answer. So what do you think is the projected price for fossil fuel-based generation in the next few years? I can see everyone voting, starting to vote. I'll give you 20 more seconds to cast your opinion. All right, guys. So 45% of you said there was a small increase. 39% said it was significant. Very few of you said there was going to be a reduction, 10%. And then 2% said it was significant. Only 4 of you said it would be around the same price. Any comments on this, Vibka or Mr. Cavalli, this insight?
Well, indeed, from my perspective, the fear of most utilities, and maybe I didn't stress this enough in my presentation, going more green also allows us with this project to be impacted less by the volatility of this oil market. We have the Caribbean region has no impact on its pricing. And hence, there's always the fear if you ask, and I'm not surprised by the results of the polls. Certainly, everyone has answered towards what the fear and concerns are most, and that's that the prices will continue to go up on average. And so, with our solution, and hopefully I see the same being duplicated or at least initiatives taken on other islands, we can move forward towards decreasing our exposure to the expected increase of the oil or fuels going forward. But I too think that would side with the two groups where they indicated a possible increase or significant increase of fuel in the coming years.
Thanks a lot. And Vibka, your thoughts on the results?
Yeah, reflecting also the expectations. So future forecast is always very difficult. We had been surprised over the, let's say, lower prices for oil in the last years, but in a long-term perspective, I personally also cannot imagine that they will go down. So yeah, we all can't have a look in the future, but they are exactly, the results are basically reflecting this.
Okay, thanks a lot. I actually, that leads into the next question that we prepared for the audience. And what should be the driving factor for energy storage applications / investment in the Caribbean? You know, given the reality that Mr. Cavalli and Vipa spoke to. So if you guys look at your screen, I'll give you 30 more seconds to vote.
Hello, Martin.
Hi there.
The third one, just for the audience, I think that speaks more to peak shaving and energy shifting. I think it says peak shifting.
Oh, okay.
Energy shifting, yeah.
Great. And as we can see from the responses, most of you thought all of the above were good drivers. 27% of you said offset of conventional generators. 10% said frequency response and spinning reserve. 6% peak shaving, energy shifting. And only 2% said reactive power production. Panelists, what are your thoughts on this result?
Well, maybe I can take on this, Martin. This is Jesus. And this is interesting to see how, I would say, aggressive the market is really seeing the renewable energy to get into or to penetrate. So, because this is, of course, the ultimate goal to offset the conventional generators, to have a truly green, clean generation. And whereas, of course, the investment for that, it's another discussion how can be done in terms of the budget that maybe each of the islands may have. But it's very interesting that the push is to really go quickly to that goal of 100% penetration of power and later of energy.
Okay. Well, any other thoughts from you, Vipka, or Mr. Cavalli?
Okay,
from my perspective, go ahead.
Go ahead, Vipka.
No, from my perspective, it's all interconnected. Honestly, as I'm presenting, I can't see even the polls. This is why I don't have the detailed view here. But obviously, the focus from one island is different to another, but it's very hard to distinguish. You need all of these functions in a system, and yeah, so this is exactly the right answer. It's very hard to separate them, I would say.
Yeah.
And I would add that one more point. I was not surprised that most of the respondents were not caring so much for reactive power supply. On Stuco also, this was not a concern at all, because we have already 55% of our medium voltage lines on the ground, and they provide a significant capacitive load for the grid. And so without the solar park, our power factor on the island is already now at 96%. So I just wanted to add that for Stucco, the reactive power provision was certainly not a major concern or even a requirement.
That's interesting. I'm gonna let you dive into your presentation. As Mr. Cavalli said, you were one of the stars in helping with this development, and I just wanted to make sure you got that feedback from the audience before we transitioned over.
Thank you very much, Martin.
Anytime.
And it's really a pleasure to present and see the big interest in the system, as it is really a lighthouse project. So my name is Wiebke Krüger, and I had the pleasure and also the privilege to represent a whole big group and team of many engineers behind me, and I could lead the project as project manager. So I want to take you today on my journey through the project and share challenges, lessons learned, give you an insight on the time schedule, and will also give you a bit more details on the performance as we're focusing on resilience today. Okay, I will start. Oh, right, I have a technical, now it's working, with a challenging. So for me as a project manager, it was the complexity of the project as such. It's not simply a complicated task to integrate 20, 30 technical devices as such, but on top of this, it's a dynamic environment. So we are in this project, we're doing, let's say, the step from small lithium applications to large-scale battery systems on islands. And we started with the first phase nearly 3 years ago. At that point in time, it was really new. It's still new, not only for us as solution integrators or provider of battery inverters, but also for the lithium-ion manufacturer as such. So it's a real challenge as there is a lack of regulations and experience on the system level. How do you define something like battery throughput, cycles? Where do you measure what? Are there standardized warranties? And it took us a while to have a common understanding with all parties involved on these technical terms. That was, one main challenge. This brings with it the next challenge, and this is a design process. So for us, in the beginning, it was the target was clear, but how to get there? So we had to design our design process first. And we got the question, how did you do it? And yes, of course, we used established software programs such as Humor or PVSys, PowerFlow. There are multiple, but that was not enough. And we had to develop our own MATLAB-based softwares, for instance, for thermal modeling of the battery system, and develop products on the way. So there were no data sheets. We had to basically write the data sheets of the components we wanted to use. That was a real challenge. And additionally, as we said, we're talking about resilience, redundancy. So we had to think about a very robust system and integrate redundancy on every component and every product, every layer in the system, and build it in the system architecture. I would have never thought that I'm complaining about not enough regulation. But as it is new, there are simply no European VDE standards, DIN norms, no ISO standards, and no UL norm. When it comes to the Caribbean islands, most of your islands, you have your very special systems. So you have different frequency levels, voltage levels, and this means that it's sometimes very hard to come with standard products. This is on top of it. So I encourage everybody who's working in gremiums to define standards. It's really helpful, and for my engineering life, I really appreciate them now. I want to give you one information. Fred mentioned it already. It's the ISO 8528.5. And this is an ISO norm for the grid quality of generator system. We just took it as a reference because we did not know to what we should compare. There is no norm for a grid forming inverter, let's say. So we more or less gave ourselves the threshold and boundary limitations of this norm and made sure we meet at least the given standards, and we are not only fulfilling but over succeeding them. The next big challenge, and this you know much better than me living on an island, are the logistics. So you see here a vessel. We had to ship 8 containers and sea containers, special containers, so not normal 20 feet. And we had 9 deliveries. You see also this little icon. It stands for dangerous goods. So lithium-ion batteries are dangerous goods. And if you want to literally ship them from one corner of the globe, in this case Korea, to the Caribbean islands, it's not that easy. They are crossing some borders. And custom has a say in it. We had to translate, for instance, 30 so-called HS codes from numeric language to Korean to English back to European HS codes. Sometimes you feel like a pioneer if you're doing these things. The next challenge, talking about globalization. I give you an example. So when we had the system running, I was of course very excited and thankful and wanted to inform the whole team behind us, everybody who contributed. And that I was standing in the powerhouse with my mobile and added people that came on the top of my head who contributed. In the end, it was a group of 72 colleagues just within SMA. We of course had suppliers and subcontractors, partners, and many, many more. Just for fun, I counted the nationalities, and it was people helping us from 22 countries. So this project was really a global cooperation, and the challenge with it is, of course, that we are living in different time zones. We're not all in the same office, unfortunately, or perhaps sometimes better. But it was also a lot of fun, of course. And with modern technology, as not Skype, but WebEx for us, we had many, many meetings in person and also online, like here. Yes, this is a challenge. It's an island. So an island is remote, and if you're on an island, it's not so easy to go to the next shop and just buy the Cat 6 plug that you forgot at home. This is obvious to the audience, I guess, and everybody who really thinks about it. But for us coming from Central Europe, where basically now everything is available in 24 hours with Amazon, it's a new thinking process. So the level of accuracy in the preparation of the execution of the project is very high. And so we only send our most healthy, robust and engineers with a really hands-on mentality on site, and they made it. On top, you have special requirements such as corrosion protection, and as I said, different requirements in terms of frequency and voltage. Last but not least, it's the internet connection, and this is some advice, or I would really ask you, if you're starting any project, don't save on internet connection. Give us access, connect your system to the internet, and it's a backbone. We can do lots of remote analysis, software support, and so on in the background. And yeah, it's your insurance. So this is one very important one for me as well. Now, time-wise, how did it look like? This is the initial implementation schedule. In blue, you see, so in the dark blue, you see actually the dates, how we arranged it, or let's say planning of January. And in light blue, you see the initial schedule. You will remark some delays, and I will give you the reason for it. Anyhow, we finished on this scale. We should have finished end of September. We finished end of October. And this 1 month delay was thanks to Irma. It took us exactly 4 weeks to reschedule the overall commissioning to come to the island. Not with public transport, I tell you, we found other ways, and it took us 4 days to get to the island. But we made it. And the slack you see between the blue colors is exactly what I was mentioning before. We took our time to define very, very well all specification for the grid forming inverter, for the battery system, for the containerization. And it took us more time than we initially thought, but it paid off. Yes, so we could have the inauguration on the 15th of November, and we were very, very happy to present everybody a running system. Since then, we are looking at it, and I want to show you, perhaps first the system again. I keep it short, as Fred has presented it before. So, sorry for this, it's an oversimplified single line diagram, high level, and this is what we found when we entered the island: a generator fleet, a grid, and loads. So in the first phase, we integrated a 1.9 megawatt peak solar system with a 600 kilowatt hour battery system, basically to compensate the PV ramps. And we even got an award for it. I said it was new at that time in 2016. As Fred told, he challenged us. He wanted to double fuel savings and shut off these gensets over the day. So the grid building inverter had to, well, yes, first of all, we had to achieve this. We simply doubled or more than doubled the PV system. Anyhow, this is not enough, as not all PV could be absorbed by the system, and it's at the border of stability. To shut down the gensets, our system had to fulfill all the functions that gensets are simply fulfilling. So it had to change from a current source to a voltage source. It had to take over frequency regulation, enough spinning reserve to cope with 4 megawatt PV and 2 megawatt load. So you can imagine these ramps. And it should be fully automatic between diesel gensets, and all components in the system. After this iterative design process, we provided 2 Sunny Central Storage 2200 grid forming inverters as completely redundant. So we have 3 battery inverters in operation in parallel, and if any of those fails, 2 take over, smoothly, seamlessly. Okay, and this looks, and we were very happy to win, for instance, the CAREC award last year in Miami. Now I will show you how a typical day looks like. So we're starting at night. In purple, you see the the power, and the power around 1.8 megawatt, which is completely provided by the genset in purple. At around 6 in the morning, you're familiar with the sunrise here in orange, and the sun goes up. Immediately, you see that the generator power is decreasing 1 to 1 until the point where the minimum nominal partial load of the generator is reached. It simply has to produce 300 kilowatt. At this time, the battery is, well, there is excess energy and the battery is charged. This goes on until around 9 a.m. when the battery has enough energy to hold the system for 30 minutes on its own. And there comes the magic transition from diesel on to diesel off mode. So we're switching it off. From this moment in time, usually around 9 a.m., we have the two central PV inverters and the small SDP inverters powering, plus 3 Sunny Central storage inverters. And we picked this graph because you see, yeah, it's you see the clouds, you see these spikes, and if you just see, yeah, do the sum. Here we are having 3 megawatt, it goes down to 1, so these are spikes of 2 megawatt, easily handled by the battery. All day long until we come here, it's getting afternoon, yeah, sun is getting lower, and the battery starts from getting charged, it starts discharging and supplying energy so that the gen sets do not have to be turned on yet. This happens. So there's a point of perhaps 30 minutes to 1 hour when there's nearly no PV in the net, but the graph would be fully blue. So the whole system or the load is provided only by battery power. Until the fuel safe controller gives the command to switch back on the generators. This happens in a couple of, yeah, basically seconds, minutes, very fast. And we see that we still have a little bit of buffer in the batteries, and we're discharging a bit more, yeah, energy in parallel to the generator. That's a typical day now. Here it's the 19th of November, and since then, yeah, looks more or less the same each day. You are interested in yeah, resilience, and we have lots of discussions about frequency. So what I did here, I picked another day, looks similar from phase 1. And on the graph below, you see the frequency. So what I want to show you with this graph is that, yeah, prior at night, it is still the generator system. But it has to be said that the PV is introducing frequency fluctuation with this heavy clouding and ramping over time, over the day. Now I show you the same graphs for phase 2. So 2 years later, again in April, again a cloudy day. And you will see that the frequency here is pretty flat. It's really flat. I show you a zoom in the next slide. So we could eliminate all these, yeah, disturbances by PV brought into the system. Perhaps you notice these 2 spikes here, one in the morning, one in the evening. And this is designed into the system. It's a droop curve, and we're sharing the load to load and unload the generators. Okay, now some more tests, or some more tests. Fred challenged the whole system, and he did not believe the paper, so really did all these tests live on the island. I tell you, that was really interesting. And yeah, we had some sweating hands as well, but it worked out. So the first test was a step load test. 50% of the load were just hardly disconnected, 1 megawatt. And this is a zoom in on the voltage. So I cannot tell you in this graph, and I really do not remember when in time this was. It's 1 hour, and you can't see it. We had some other measurement equipment which should have registered the spike, but it actually did not register any spike. The voltage fluctuation is of 0.4% during that hour. Again, a look at the frequency. I picked these days because we had a very high resolution Fluke measurement device and at the same time span. And you see that the frequency stayed in a bandwidth of 59.992 to 60.005 Hertz. It's very close. And I have some other tests. So the short circuit was mentioned, and this is a test of 30 amps. It was actually a spectacular test, and I can tell you that we have blown some fuses. And you can see that in this high resolution 10 millisecond measurement, the grid is stable. Then we have here the clearance happened after 120 milliseconds, and the grid, is fully working again. Everything was simply continuing working. You see the influence, so the voltage drop and the frequency drop a bit later on. The frequency dropped only about 0.7 Hertz. No, not 0.7. It dropped to 58.2. Yeah, but still, well, for such a massive grid disturbance, a very good value. Last but not least, I'll show you the very interesting, we call it UPS test, the uninterrupted power supply test. And this was a situation Friday night, 8 p.m. Party was going on, sun was down, and we had 2 megawatt load. And we skipped the smooth transition between diesel on and diesel off, and just disconnected hard the generators. The next slide shows you the power of one of the 3 Sunny Central storages. So sharp disconnect of 2 megawatt load. You will see that the Sunny Central storage 2200 took 800 kilowatt instantaneously. The frequency dropped, well, here it was 0.7 Hertz for about 300 milliseconds and recovered very quickly. So since then, it happened 7 times that our system could prevent a blackout for a generator failure. Yes, we are looking at the system, of course, remotely from time to time. And most interesting is, of course, how many hours can we achieve an diesel off mode? And so far, we've seen 11.5 hours so far. Yes, and this is basically all that I have prepared for you. If you have questions, I'm more than happy to answer them.
Sorry, I was on mute. Thank you very much, Vivka. We do have some questions coming in. We actually have some comments as well. They're very impressed with the process. Someone wanted to know who was the manufacturer of the racking system itself.
The racking system, so for the PV, yeah. I understand. And then this was in the scope of Eco Energy, and the manufacturer was Schletter, based close to Munich and Haag in Germany.
Okay. And we also someone wanted to know, and I guess this was towards everyone, what is the return on investment time for the project estimated?
This I have to give back to Fred.
Okay, again, the driving factor for initiating this project was the Dutch government not desiring to continuously provision about $2 million per year towards a subsidy for operation losses due to fuel. And so what they did basically was granted the funds for the project, So it was a donation. Phase 1 and phase 2 together would be an amount of about $14 million. And if you do the math of about $2 million fuel offset per year, that's for them, that's a payback time of 7 years. Given the expected lifetime of the project, you all know that for them being the one that was subsidizing $2 million per year, this has been a great success to be able to together find such a solution.
Okay, and I noticed I had a message come in actually on WhatsApp from a non-technical person. They wanted you to explain what do you mean by grid forming. Yeah.
Okay. Good. So normal PV inverters are only working if they see an external voltage and frequency. And these appliances, well, internal, yeah, they are like a current source. So basically, if you have a PV inverter, you can't switch them on. They have to see an external voltage. And then you have devices like generators, where you, yeah, how to say it, you start them, they are running on their own. And this was never done to a, yeah, the battery inverter on a megawatt scale. There are appliances like the Sunny Island who can have this function, but so far we were limited to, well, 300 kilowatt in total by adding them up in parallel. So it's a new, it's really a new technique. It's another control scheme.
Oh, great. Great, thanks for that.
I'm not sure if this is, if you have other words, Fred, to make it more easy, but non-technical.
Maybe, yeah, perhaps just to mention that they can create the grid reference of frequency and voltage. So you can shut down or switch off conventional generators. That's the main purpose, I would say, to summarize it for someone non-technical. So you can have 100% penetration from renewable energy, thanks to this grid forming technology.
Okay.
So basically, I would just simply add, conventionally, PV inverters, if you have a solar system at your home, should you lose power supply from the grid, you cannot use your PV inverter conventionally. The power supply to your house or home or business goes, you have a PV system, it shuts down. With the grid farming inverters in phase 2, we supply, there's a PV system that can supply not a home but the whole island, and you can shut the generators down and it continues to supply the island. So it then supplies all the functionalities of a power system to generate voltage and frequency to the entire island. So that's the grid forming part, which is not possible in normal or conventional PV inverters that you would find at your home.
Okay. And we had someone ask Vipka if the system, when designing it, does it have a relay protection scheme or a fuse coordination protection scheme?
Yes. So on every level you find, yeah, of course. The protection is one of the most important design steps in it. So on every level there are fuses, circuit breakers, and of course they are, what is it in English? Well, the selectivity. There is a selectivity process behind it. And yes, it was very interesting from the grid topology because Stuco also invested in analyzing the grid topology, and there had to be a couple of changes done because Previously, all the power, let's say, came from the power plant, and now you have on the other side of the island, so on the other side of the grid, a device that feeds in large amounts of power. So the direction changed, and therefore there had to be certain upgrades on it. But yes, from our system, you have protection in each battery module and each battery rack on the inverter level, DC, AC, and basically on the transformer level. So yes.
Great. And a question came in as well around how many days of autonomy can be achieved. So how many days could diesel off be achieved, and how many days is diesel off not possible?
Okay, it's not in conventional small scale, something like solar home systems or sunny island systems, where we're designing for days of autonomy. Basically, the game starts every day again. So we discharge the battery nearly to zero. We keep a tiny little bit of state of charge for this UPS function mentioned. Then we need some energy, but something like we discharge it around 10%, let's say. And then as soon as the sun wakes up, it's charging the battery. So in principle, it's every day. But the night, currently, we cannot cover the night consumption. And this is usually what is defined with days of autonomy.
Oh, okay. So it's basically battery cycling that you guys do.
Yes, it's like in terms of battery size, we're under one cycle per day. We're at 0.7 approximately, depending, of course, on irradiation and consumption. But in the average, and we're not providing nighttime power. Usually what's meant with days of autonomy is that if the battery is full and the solar is shut off or just rainy period, it won't be charged and the battery continues for 2-3 days to provide the entire power. But this is not economically for such large projects.
Great. Thank you for that.
And just to give a perspective, in her presentation, she indicated that usually we see diesel off mode starting at around 9 a.m. and usually at around 7 p.m. at night, it switches back to diesel on mode. What we have seen, of course, is some variance to that. We've had as early as somewhat just before 8:30 a.m. in the morning, that the system went to diesel off mode, and up to about 8:30 at night, 8:30 p.m. That was basically our longest time that we've seen from after 8 in the morning to about 8:30, almost minutes to 9 at night.
Great. Thank you for that. And I guess now we want to engage the audience again. We want to know how much experience does your utility have with operation and maintenance of PV projects? So if you can, please explain if you have no experience, less than 5 years, 5 to 10 years, or over 10 years of experience working with PV. I know this question is geared towards utilities. So some of you are joining from outside, but we want to really contextualize our experience in the Caribbean so we know how to move forward. So just bear with us for another 20 seconds and I'll share the results. So 48% of the attendees said less than 5 years, 27% said no experience, 15% have 5 to 10 years, and 9% have over 10 years. I mean, Mr. Cavalli, you've had your experience working in the region for a while, and even myself with my short experience in the region, I've seen a rapid increase in photovoltaics, and I think this is a global trend. Have you noticed this as well, the rapid shift in the region?
Yes, basically for Stucco, of course, we fit within that 48% because our system is less than 5 years old. We started talking about PV power in 2014 and have realized 2 projects in a very short period. And because we are utility and we're familiar with AC powered systems, and we were focused on the execution and realization of the projects, of course, we too have a need to build our PV experience and expertise in the company. So what we did was, with the lead contractor, we signed a 5-year maintenance agreement. Within that 5 years, the contractor is responsible for maintenance at the PV park and battery systems to a certain degree of expertise. And in that 5 years, after that 5 years, we will go along with them. And after 5 years, Stucco will assume that responsibility directly. For the more complex systems, such as the large Sunny Central storage and Sunny Central inverters, we have contracted SMA for 10 years. And also we maintain, as we've indicated, a critical requirement that they have access to the systems remotely via a direct access, call it VPN or whatever, but they have a possibility that they can continuously look into the system. So yes, indeed, all of us, for the most part, are just getting into PV power. It's blowing up exponentially in the region. Everyone is acquiring some PV system. Because I think that is the best option, if you ask me, for our region, given the risk of the hurricanes that are passing, that we can install a resilient PV park that can resist Cat 5 storms.
Okay. And then I'm just going to launch one more poll, based on that. CAREC, we want to understand where your training needs are as utilities and as islands, and share these experiences that we've been doing. So we wanted to know how many of you have dedicated, how many persons do you have dedicated at your utility towards renewable energy projects or research? And via CAREC, you can reach out to us, because I guess I put this in here because I want to understand, who these persons are, so we can connect them and share these conversations and experiences as groups. So as we can see, 46% said less than 5 persons. 34% said not applicable to their organization, because we don't just have utilities on here. 5 to 7% have 5 to 20 persons, and 5% have 20 plus, and 7% have just one. So I open this up to recognize that we're all at different stages of solar or renewable energy development, or even considering it, and uh, like this transition is happening slowly, rapidly, and we're here to just learn from each other. Any comments on this, Mr. Cavalli?
Okay. Being that we are a very small company for provision of electricity and water, I think we're staff of 22 persons. The foremost person that is involved with initiatives in renewable energy, that would be my person. However, the power plant, we have a group of 8 persons that work there. And the fact is, we now, for most of the day, basically gensets have been shut down. So it is this group of persons or personnel that will be trained within the next coming 5 years under the maintenance agreements that we have, to assume the knowledge required to execute all maintenance at the solar park. So where research is concerned and initiatives, that's my person. And where others getting involved with maintenance and operations of the PV system, we have a group of 4 persons directly in maintenance and another 4 in operations that will, during the next 5 years, be their work job function will be adjusted to, so that it can contribute and make activities also in our PV system. That will be a requirement.
Great. So I'm going to hand over presentation to Jesus to let him finish up the presentation, but then we're going to have the Q&A. So submit the rest of your questions to the question dashboard, and in the remaining slot of time, we'll discuss with the team any additional questions. Jesus, over to you.
Thank you. Thank you, Martin, and thank you, Fred and Bipke. And thank you to all people that are connected to this webinar. For those that maybe join later, that join late, my name is Jesus Martinez, Business Development and Sales Manager for Hybrid Energy Storage Solutions at the SMA Group, and I'm particularly responsible for the Caribbean market. And today I'm going to continue the webinar to broaden the discussion for applications and solutions for renewable energy and energy storage that we see particularly in the Caribbean market. So for those of you that maybe wonder how a similar application or a similar system as it is in East Asia could apply to other islands, 100% or perhaps likely in a way that could be different, and that's my intention to broaden the scope of solutions. So let me start. Not sure. Okay, now you see the first slides. Before going to broaden the discussion, first I'm going to give you a brief introduction of who we are. I think this is important for you to know where we come from and how we are now providing such or high complex solutions in the Caribbean market. The SMA Solar Technology Group is or has over 35 years of experience focusing on the PV inverter, battery inverter, and smart integration of solar technology. For 35 years around. We have a healthy situation financially. in the last years or all over the company history. We have a total installed PV global capacity of more than 70 gigawatts. So we are one of the world leaders in this aspect. Whereas for the battery systems, we have over 100,000 plus systems installed. And we have a strong investment for research and development for such solutions as it is or was the case of Synestations, already mentioned by Fred and Vibke. And we count with over 3,000 employees all over the globe. So in the last decade or the last years, as the discussion for the increase of renewable energy penetration into the grid started or was coming for some regions or some grids. For instance, in the Caribbean, SMA decided to found the entity SMA Sunbelt Energy, GmbH, which is a 100% affiliated company to the SMA Group, focusing on, as I said, these discussions for large penetration of renewable energy, typically found in off-grid, hybrid, and battery-based solar projects. And by being involved in these discussions, SMA found that the solutions and also the services that could be provided were out of the classical approach of the SMA solar technology focus. So therefore, SMA Sunbelt Energy is now in place, providing a more diverse or broader scope of supply possibilities, going from engineering, procurement of all components, and construction support in these kind of projects, PV hybrid and energy storage, particularly focusing on what we call or what is known as the Sunbelt region, comprehending Africa, Central America, the Caribbean, Middle East, Southeast Asia, and Pacific regions. And from my end in particular, I've been for the last 4 years trying to promote such systems in the Caribbean region, and I'm really glad and excited about the development in the recent years, and we hopefully look for more projects in the future. When we look to the Caribbean region in particular, we see that there are different needs because there are different challenges and opportunities for PV and energy storage. This is because each island is unique, of course, but they all, in recent years, see a clear opportunity for the saving on generation costs with the implementation of renewable energy. The main driver that is causing this trend is because of the declining of prices, on one hand for solar PV energy, that's been seen in the last years. For instance, just to tell a study for the US mainland that found that solar PV energy is actually cheaper than all liquid fuel generators and cost comparative with combined cycle gas turbines. So to think of what it is for the Caribbean, I think it's a clear reason of the attractiveness for solar PV in the region. And on the other hand, a way to increase the penetration of renewable energy is the battery technologies, which also have a trend to reduce prices in the last years. For instance, a study 2017 from Green Tech Media showed that the reduction of costs had been 70%, and since then it's actually continuing to fall the prices. So those are, let's say, the main drivers we see for utilities in particular to look into the technology. But of course, the challenge on this aggressive integration of renewable energy has to do with the nature of the energy, renewable energy, which is intermittent, and this means that the risk power variability reduces the grid inertia in the grid. So that's why it is very important to do a proper analysis for the sizing, location of the power generation of renewable energy, the fast regulation, and as I said, the additional integration of energy storage to increase the inertia and allow a larger penetration above 20% with controller, and with energy storage that could increase to above 60% up to 100% with grid-forming battery inverters. So we at SMA understand the particularities, and we offer different solutions based on the PV size that can be integrated. This was something briefly mentioned by my colleague Vipke, but we see, for instance, in those systems with relative small PV capacity that could be installed, typically in off-grid applications, where you can have a high penetration with a relative small PV system. You can also look into the addition of energy storage to cover a high or a large time of autonomy. So typically in such systems, you can have or size the system to have a couple of days of autonomy, since the investment may not be significant, still talking about the kilowatt range investment. So when you jump to a larger size of application capacity, we suggest to go, for instance, as it was the case of Zenith stations, to have implementation per phase, in which you can have the phase integration of renewable energy to have up to 20% without the need of any controller. If you want to increase that number up to 60%, you can do it with a grid controller. In this case, SMA grid controller, as it was installed in Zenith stations. And later, you can also add battery to provide spin reserve, switch off generators up to 100% if you can add the grid-forming battery inverters as we had in Stasia. So that's perhaps a solution for many of the islands. In particular, I would say in the Eastern Caribbean, many of the islands could have this approach and learn from the experience of Zenith stations. And finally, maybe for other larger islands, where we could talk about large grid distances from the generation to the consumption, and also the investment for energy storage to have a large penetration may be considerable, then the approach or the solution could be what we call the grid-connected battery applications that can facilitate the firming of renewable energy to provide a stable injection of renewable energy to the grid, but not necessarily connected to renewable energy. Can also be integrated due to the nature of the grid that maybe features some need to improve the quality of the power. So as you see, there are different solutions depending on the complexity and also of the size of the renewable energy that could be implemented. And this, if you look now to the location of these solutions, there are a multitude of applications for storage that can bring benefits to the utilities. So looking here on this slide, I can mention, for instance, on the left, the integration of energy storage can be an advantage to provide a black start capability to conventional power plants. And for the renewable power plants, as it's seen in Senus phase 1 was providing, the energy storage was providing ramp rate control, frequency control, whereas the second phase, with the grid forming battery inverters, we could switch off the conventional power plant. So this could be benefits for the operation of the utilities. Then later on the distribution throughout the grid, the energy storage can provide a reactive power supply, dispatch, and scheduling of power. So typically ancillary services throughout the grid. And also the energy storage could be located next to the consumption loads. For instance, in large commercial loads that require a sudden peak power demand. So instead of maybe requesting that from the grid, they can install their own energy storage to meet this power surge during certain hours of the time. So what will be the peak shaving application? So, and perhaps on this slide, I would like to raise the discussion that could be interesting for the audience today. Who would be, or who do you think would be the best entity or the owner of the assets of the energy storage, depending on the location? So this is something that from our perspective, from the technology provider perspective, we have solution as is shown here for any of the options or the possibilities. But in the actual implementation, I believe that it's really important that utilities must be involved in the decision of such investment. But the discussion of who will be the owner, that's something also to align with the policymakers in the islands. So now I'm going just to jump to provide you a basic schematic of a large-scale storage system. So that basically is what we provide as a Sunbelt as a solution. So you can see here on the upper part, the battery energy storage system comprehended by the energy storage battery bank, the battery modules that you have to integrate with a power conversion system consisting of the battery inverter. In this case, our SMA semi-central storage that could be implemented in a compact station with the medium voltage transformer and the medium voltage switchgear in a 20-foot container to inject in the medium voltage to the grid. And that could be installed itself without the need of renewable energy, as I just showed before. But if you see or you invest in the renewable energy, that could also be integrated in the same communication towards the SMA grid controller, which is let's say the system or the component that decides basically looking into the grid behavior, how to regulate the different power sources, either the renewable energy power sources or with the combination of the energy storage to compensate any fluctuation on the grid. So what it makes different SMA Sunbelt, and we look into project for the other islands, is how we can provide the different services from the engineering part in the beginning for the sizing of the batteries properly. As mentioned by my colleague Pipke, we had developed an in-house engineering process, basically with a software that can simulate the output of the batteries and have a detailed load profile for the battery degradation, which is also important for the long-term design of the project throughout 10, 20 years lifetime. And based on that, we designed the battery that can specifically meet the need. So instead of having a solution that we say that should be applied, we rather look into the need and tailor what solution can meet the need sustainably and successfully for the lifetime. And we later on the engineering actually of the physical components, for instance, of the containers of the batteries, we can do or perform the adaptations and design for a complete system, including the electrical and mechanical drawings for utilities in the operation of such systems. So basically, we have already, as mentioned, experience in these projects, SMA for the 35 years with over 100,000 systems already installed, and this has allowed us to have collaboration with tier 1 battery manufacturers already, so we can cooperate with them not only with lithium-ion technologies, which maybe are the most common now technology due to the I would say price aggressive price that you can find in the market, but also with other technologies that have different chemical properties and also can be suitable for other applications that perhaps are still young, but definitely could develop for the future. So this allows to be flexible and to look in, as I said, into the needs and be flexible on the solution to provide. So finally, also I'd like to invite you to have a look on, in particular for the Synesthesia case in the media. We have some videos to have more visual knowledge of the implementation of the project, the installation, and the commissioning process that took place last year. Also to have more information about the discussions that have started in our blog, and also references to the awards that Synesthesia have been received in the last years. As mentioned before, the phase 1 for we received the Intersolar Award in 2016, and recently the CAREC Award last year for phase 2. And we believe that there are still many others yet to come as we develop this system and others in the region. So finally, just to close, on behalf of my colleagues Fred and Vibke and Stuco and SMA, I would like to thank your attention, and we are now open for any question that you may have now or later to follow up.
Thanks a lot, Jesus. I'm just going to dive straight into the questions regarding the Synesthesia system. Colin from Grenada, well, he had a comment. He said he was very impressed that Fred, you focused on collecting water that you did water harvesting. But he also had a question regarding how has the island's tariff been impacted by the system?
Okay, the tariffs. There's the electricity and water law that regulates how the STUCO goes about setting tariffs. There's the regulator, and electricity and water law basically says that the tariffs should be cost-based. So certainly, had the Dutch government not get involved at all, they would have had to continually subsidize, and this is not the policy of the Dutch government to subsidize power companies as such. So therefore, they provided a subsidy, donation, grant for the solar park to offset, basically offsetting the subsidy, that the structural subsidy that they were provisioning on a yearly basis. And this has allowed us to not, or to maintain the rates more or less under even a different tariff structure that we had coming out of our relationship with GEBE. So to answer that question, we were able to maintain the basically the same tariffs, and now the subsidies are no more. So STUCO can now move forward in maintaining the rates that we started with on January 1st, 2014.
And thank you very much for that, Fred. We had a question regarding kind of the size of the project. So how much land space was used in the construction of the solar park? And do you also have options for having livestock in helping with the maintenance beyond the harvesting? This came in from Kern of St. Lucia.
Yes. I think the entire park probably takes up about 50,000 square meters. About the entire space available to us is just over 80,000 square meters. So we are even considering a third phase. Yes, the idea, of course, is on an island, and the location of the park sitting on some fertile soil. So you have where the bushes, the vegetation is growing, and that's an additional cost for STUCO. So in coexisting with the agricultural activities, no, there won't be any animals in the park. We thought about doing that in the first instance, planting grass that the animals can eat. There's no fear of the animals breaking their lines because they're more interested in what's on the ground, so their heads would be mostly down. Even these days we have animals in there because we have not really regulated the agriculture or implemented that aspect as yet. So the park is full of animals, and their heads are down. So we have no issue with that. But actually growing agricultural products has a more greater need right now. So what we will do is assign different responsible farmers areas that they can cultivate under the panels, and they at the same time would be responsible to keep clean the vegetation of that particular area. And in that case, in that way, STUCO has like a win-win. They take care of the vegetation, we don't have that cost, and then they can coexist with us on the park.
Okay, thank you for that insight. We actually had a question for Wiebke. From your experience, which tests are crucial for off-grid balances and must be carried out on it for any off-grid application in the future?
That's a very good question. So, well, what tests? Every system is designed slightly differently. So I would test, for instance, we tested something like communication loss, because it can easily happen that communication between different systems are not there. We tested the UPS function as we had it, and of course, very important is the short circuit power provision. This is, I would say most relevant. That we have partial operation if we lose racks, so of course we tested that. We switched on and off all the devices. So let's say we have built in lots of redundancy, and we tested all of them. To be sure, we're working in partial operation with only a couple of solar inverters, only a couple of, well, not only a couple of racks, but let's say they can fail up to 3 racks per container of the battery. And this we tested in every order. But it depends very much now on your setup, on the topology. So I would say communication loss, short circuit provision, and then of course these partial operation and switching on off. Yeah.
Thank you very much. Actually, you mentioned the word redundancy, and that was the next question pointed at you. What level of redundancy was required for the St. Eustatius case in particular?
In particular, it was, let's say, very, in my perspective, vague. It was asked for a redundant system in terms of, well, of course, electricity power, but also communication. And so, as it was, as I said, the first product for us as well, it was important to have a redundancy on every level. So we built it in software functions. We built it in fiber optic ring topology. So there's a hot standby from the SCADA server. There's RAID 5, so it can fail. In the tender document as such, it was not specified due to the fact that the whole topology was not really given. So it could not have been specified deeper.
Okay. Actually, we have a question geared towards you. We've, more specifically of you as a woman working in energy. What has been your experience working in energy and then working in the Caribbean as a female? What advice would you give to other female engineers about your line of work?
Okay, that's really another topic.
I know.
I'm not often thinking about this because I'm simply used to it. Being often the only female, though I have to say within SMA Sunbelt, we're having now our battery specialist. She, is a female engineer, and at SMA AG, so our mother company as well, the battery specialist is, a female, a lady. For me, I personally only had good experience. Sometimes I see surprise when I meet engineers, to see me. But so far, I think they were so surprised that they never challenged me. When I started presentation, I usually got relatively good, direct feedback, and I was accepted. Though I must say also that I was always pushed and supported by all of my teachers, professors, and also my chefs in the companies I've been working for. So I can only encourage every lady to join the energy world. It's interesting, and I have not seen any limitations for me so far. And that's why I'm also holding like presentations next week at a university to get young people engaged in this very interesting topic. And so why not? There's really, it's a lot of fun. Join, ladies, join. Do we have any ladies here in the audience?
Yeah, we have a lot.
That's awesome. That's really good. So personally, no, nothing negative, only positive. Okay. And I would be very happy to see more of you.
Okay.
Martin, may I simply add that after this group won the tender of phase 1, of course, after the contract was signed, there was a kickoff meeting, at Stuco's office in the conference room. And this is the first time that I met the group from SMA. So I came in the room after everyone was sitting, and I said, okay, they introduced, to be introduced, I said, well, who's the project manager or leader from SMA? And they said, she said, well, it's me. And I said, oh, it's the lady, you know, because I was expecting as is the dominant factor in energy that would be a man. And here it was, I was confronted with a lady, a young person, and I can tell you that I think it was the very best choice of SMA to have Wiebke been the one to spearhead the project. As the project manager, I think it boosted and contributed significantly to the success and delivery of the project. I don't think I would have desired a better project manager from their side. So Wiebke, kudos to you.
Thank you.
Thanks a lot for that insight. It kind of fits in with the narrative of one of CARILEC's partners, the Women in Renewable Energy Network, which is a mentoring program for energy professionals. And I'll share some information about that with you as well. We have some other technical questions going back now regarding the lifespan of the batteries and how often you have to change them. Also wanting to find out more about any diesel gensets that are there. How many are there, and how often is their maintenance as well?
So perhaps I start with the battery. They have a performance warranty of 10 years, and the simulated lifetime is between 12 and 15 years. So the lithium-ion battery have a calendar life, and aging depends on many key performance indicators. So we are closely looking at them, and we have defined with the manufacturer, Samsung SDI, a so-called operation window for all of these key performance indicators. And if we stay with the system operation in this given framework, and this is, well, what should we do else? It's all automated, so we have these parameters configured. Then the battery will age accordingly, and it should last 12 to 15 years. It's new, so there is no, like in PV models before. So as it was introduced to the market a couple of years ago, there is no 20-year performance experience, of course.
Okay.
But it's, but so far we are over the simulated values in terms of efficiency and aging. So they're performing better.
Great. We actually have another question at you, because you mentioned that.
I think there was a second part before we could continue. Someone asked about the gensets. We have 8 generators that are integrated with the system. 5 Caterpillar 3412s, 1800 RPMs, and 3 in the 3500 series, 1 3512 at 1200 RPM, and 2 3516 at 1200 RPMs. And they are all integrated with the system with the Woodward EasyGen controller. And of course, we have seen the numbers are not yet computed by the accountants, but of course we have seen significant drop in the maintenance requirements for these gensets.
Thank you for that. Thank you very much. We actually had a question come in regarding the planning phase and modeling phase. You mentioned, the use of Homer PV-Sys. Curtis, one of our attendees, would like to know, what was did you use MATLAB to look at thermal modeling for the batteries, or was it used for other aspects of the design stage?
Yes, thermal modeling for sure, and we also had some models on ramping. So for instance, humor is very energy based, but it's very difficult to integrate losses on it on a detailed level. So we worked simply, well, we had all different kind of tools and had to make sure we are adding them up and feeding them back into a already processed form, for instance, to humor. So yes, MATLAB we did the thermal modeling and a couple of ramp situation also on MATLAB. So let's say we examined always the best normal and worst case for many situations, and these we modeled partly as also in MATLAB.
And Curtis also asks for all the attendees, with regards to the height of the panels, are there any advantages or disadvantages to modeling to raising the height to the height that you did?
Fred, is this for me?
Yeah. Okay. Advantages that we had, of course, is when the panels are that low from a technical perspective, they are not so-called maintenance friendly. Because if there's a maintenance aspect under the panels, then one has to stoop very low to get under there. If there's vegetation growing, it's difficult to clear that vegetation. And certainly if the land is inclined, it's difficult to work with erosion. So there were some technical benefits to us for raising the panels. But foremostly, one of the secondary most beneficial aspect was that we can coexist and have, because one of the downsides as I see it for PV application is the low power density, so it takes up a lot of space, and then it just sits there. So if there's a opportunity to coexist with some other activity, I think this should go for it.
Great. And like, this is an amazing project. Congratulations to you guys on this. One question that we have is what would you have done differently? Is there anything, looking back on your experience, where were you most challenged, and how would you change this after completing the project? I know that's a tough one.
That's a tough one.
It's a tough one because as compared to other project executions, or even from the inception with feasibility studies and so with our consultants, it developed quite rapidly, and I think it's a plan of approach and focus that one gives to the project. So for me, based on the fact that we were able to hold to our time schedule, I think, and the performance, of course, of the system, it's difficult for me to come up and conceptualize some more better or more efficient or effective way that we could have executed the project. I think I will need to sit in a room and brainstorm with Wiebke and see if there's some way, along with her engineers, if it could have been done better. But it's really a good project where it can showcase what's possible and how from conceptualization to execution can be done in an effective time frame. I only have good positive remarks for the solution that we found here. So it's difficult for me to really come up with aspects that could have been improved on. I think if I give it some time, probably tomorrow I can give you some aspects on that.
Same for me. There are no real regrets. And you mentioned the black start. So this is the function we had to, well, simply postpone. Of course, I would have loved to integrate it straight away. Good news is that we're integrating it in a similar system this year in Tahiti. And so we will have the solution on the paper. It's already there. Now it's on the ship. and this will be implemented this year. One thing I remember is that we wanted to go, or you wanted to go for automized switchgear, right? That is at the moment manual one switchgear, but that's it. So we had natural catastrophes, we had missing packages, we had luckily no illness. We had a vessel which the motor breakdown, and we had lots of incidents, but there was nothing that really, no real big mistake or regret on it. So thanks for this. I'm very happy.
Yeah. And I guess, Mr. Cavalli, I guess in the same vein, people ask, like, what is the biggest thing that you learned in your experience that shocked you about the project, and given your experience in St. Eustatius, one takeaway that was like, wow, this project was different because...
Well, certainly the frequency and voltage stability response in grid forming mode, or even in support mode of the power plant. I was surprised that a static system, because it's a static system, can generate frequency and voltage to the degree of accuracy and resilience also that outperforms our power plant. Really, for people that understand diesel power generation, a power plant is a diesel engine or some rotating device that takes care of all our grade requirements. And here we have a static system that really outperforms all the requirements or expectations that you can have of a diesel generating plant. So and on all levels, it even functions as additional feature as a UPS backup for the entire island. And as we mentioned, there have been occasions 6 or 7 times since we commissioned the plant in early November that we've had an engine fall off at the power plant offline. Usually this would lead to at least load shedding or a blackout. And this was avoided on at least 6 or 7 occasions because the solar park or the grid forming function and UPS function is constantly on as a watchdog to give support to the power plant. So for me, it's just an amazing performance and ability of a static system to mimic the behavior of a power plant.
Well, I know you guys have extended beyond the time allotted for the presentation because it was such a rich and great presentation. I thank you very much for that. I have some final polls for the audience, just because we want to make sure that our content is as applicable as possible to your needs, given that we were dealing with energy storage. The first question I have is, what aspects of energy storage are you most interested in receiving training around? Is it the procurement and financial considerations, or is it around the technical operations and maintenance, or maybe the safety and environmental considerations, or the regulatory considerations, or just all of the above? Great. So most of you said all of the above, and I kind of figured that, but this gives us a good understanding of how we should shape our workshops, or even have future webinars and case studies from the region moving forward and from outside. Just some final polls. regarding this webinar for our own understanding, could you please go ahead and rate your satisfaction with the webinar series? Thank you very much for voting. And finally, well, I have two more questions if you have the time. The last one is, do you plan to apply what you learned in these webinars? Do you strongly or not so strongly agree or disagree? And like I said, this is to make sure that CAREC is there for you and your learning needs. As many of you would have heard, in September we'll be having CARILEC will be hosting the CAREC Renewable Energy and Smart Grid Conference in Miami from the 23rd to the 27th of September. So we are trying to collect information on your particular utilities learning needs so that we can shape our agenda. And, you know, if you're interested in getting involved, you can also reach out directly to the CARILEC team as we plan this moving forward. It will be an interactive style conference. We hope to really touch on the issues that are challenging the utilities and the islands and how we can move this forward, gathering up all the lessons that we've learned so far. Thank you for the poll. And finally, you know, CAREC is a free tool for everyone to use. So we also offer training on how to use the platform. Before we used to do regularly scheduled ones, but now we want to know if you would like a training tailored for your utility or organization on how to use the basic functionality. We are currently upgrading the system and we'll launch that soon at the CEO conference. So I just wanted to get some feedback from you. And if you're not a member, please go to community.carilec.org and sign up. Our goal is to connect, collaborate, and innovate and move everything forward. But in order to do that, you need to participate. So enough of that alliteration, and thank you very much for joining. We'll see you at the next.
Martin?
Hi.
Martin?
Hi, Fred.
Just a quick question. Were you going to show the results of the last 3 polls?
Oh, okay. Those were for internal.
Okay. All right. Okay, I didn't know that. Okay.
We could have a convo after.
Yeah, we'll follow up with you, Martin.
Yeah. All right, guys. I'll give you just 10 more seconds to respawn. I still see that 75% of you have voted so far. So I know some of you might be busy, and but you can always contact our team if you're interested in the trainings, in getting specific topics on the agenda. We'll continue to work with your utilities if you have a lesson to share with your experience with low carbon technology, because it can be energy efficiency as well, not just renewable energy. We want to make sure that the efficiency of the utility process is improved by using this online community, and it's free to sign up. So as I mentioned, go to community.carilec.org. And to my guests, thank you very much for your time and staying a little bit extra. It is much appreciated. And the audience can connect with you on CAREC because you're members. You can post a question and tag Fred, Jesus, or Vibka on there. Thank you very much, and we look forward to having you next time.
Thank you, Martin.
Thank you, Martin. Bye-bye.
Very welcome.
Thanks. Bye.
Bye.